You know when you see a number that's so long it just looks like a typo? Well, we're going to dive into a super cool math shortcut that makes those giant numbers and even super tiny fractions way easier to handle.
All right, so to really get why this tool is so important, let's kick things off with a little story. Picture this. There's a student named Peter. He's at a museum, and he's about to run into a number that's, well, ancient. So Peter walks up to this huge dinosaur skeleton, right? And the sign in front of it has this number that's just a massive string of digits. I mean, we've all been there, haven't we? You see it, you know it's a big number, but how big exactly? Just trying to read it feels like a total headache. Whoa, yeah, look at all those zeros. That's 100 million. It's clunky to write down, it's a pain to read, and can you even imagine trying to multiply or divide with that thing? It's just a lot.
Okay, so this is the exact kind of problem where you just know there's gotta be a better way. Whenever something is this messy and complicated, there's usually a smarter, cleaner way to write it. And lucky for us, when it comes to big numbers, mathematicians came up with a really brilliant solution.
So what is this brilliant solution? Well, it's a kind of mathematical shorthand called exponents. Yep, this is the tool that's going to take that crazy long string of zeros and turn it into something super clean and easy to work with.
Okay, so what is an exponent? Think of it like a tiny instruction manual. You've got your main number, that's called the base, and the exponent is the little number that sits on its shoulder telling you exactly how many times to multiply the base by itself. Seriously, that's all it is.
So if we go back to Peter's number, that 100 million, that's just what you get when you multiply 10 by itself 8 times. And here's the cool part. Just count the zeros. 1, 2, 3. Yep, 8 of them. That's our big clue right there.
So instead of writing out 100 million, we can just write a 10 with a small 8 right next to it. The 10 is our base, the number we're multiplying, and that little 8 is the exponent, telling us to do it 8 times. We read it as 10 to the power of 8. I mean, come on, how much cleaner is that?
But here's where it gets really powerful. It's not just about writing big numbers more neatly, it's about the super simple rules you can use to actually do math with them. So, let's jump into the basic rules. First up, we've got the product rule. This is the one you use when you're multiplying two numbers with exponents, as long as they have the same base. And trust me, it saves you from doing a ton of calculation.
So here's the trick. You just add the exponents together. That's it. Take a look at the example. 2 to the power of 3 times 2 to the power of 2. All you do is add the 3 and the 2, and bam! It becomes 2 to the power of 5. So simple.
All right, and as you've probably guessed, if there's a rule for multiplying, there's one for dividing too, and it's just as easy. When you're dividing powers with the same base, you basically just do the opposite of what we just did.
Yep, you guessed it. You just subtract the exponents. So if you have 5 to the 4th power divided by 5 squared, you just do 4 minus 2, which gives you 5 to the power of 2. It simplifies everything right down.
Okay, now for a fun little brain teaser. What in the world happens if the exponent is 0? It sounds kind of weird, right? But the answer is always the same, and it's probably the easiest rule of all to remember.
And here it is. Any number raised to the power of 0 is 1. Always. It doesn't matter if it's 5 to the power of 0 or a gazillion to the power of 0. The answer is just 1. A bit strange, I know, but it's a super useful rule to have in your back pocket.
Okay, so like with any new math concept, there are a couple of common pitfalls. So let's talk about the spots where people usually get stuck, because if you can get these down, you'll be set. All right, this is a huge one, so listen up. A negative exponent does not mean the answer is a negative number. That's what everyone thinks at first. Instead, it's an instruction to flip the number, to find its reciprocal. So 2 to the power of negative 3 is not negative 8. Nope, it's 1 over 2 to the power of 3.
And there's a simple 3-step process for this every single time. As soon as you see a negative exponent, first thing you do is flip the base, turning it into a fraction. Step 2, keep the base the same. And step 3, just make the exponent positive. So, for example, 10 to the power of negative 2 just becomes 1 over 10 to the power of positive 2.
Now here's something that might surprise you. You wouldn't think a little bit of punctuation would make such a huge difference in math, would you? But when it comes to exponents, a simple pair of parentheses can totally change your answer.
So let's break this down. On the left side, without the parentheses, that negative sign is kind of just hanging out in front. So you do 3 times 3 first, which is 9, and then you stick the negative on, making it -9. But on the right, those parentheses wrap up the -3. That means the whole thing is the base. So you're multiplying -3 by -3, which gives you a +9. That's a massive difference.
So you might be wondering, okay, why are we bothering with all these rules and traps? Is this just for a math test? Absolutely not. Exponents are literally the language scientists use to talk about our world, from things that are unimaginably huge to things that are incredibly tiny.
Seriously, they are everywhere. Astronomers need them to describe the insane distances between stars and planets. Biologists use them to calculate how fast something like bacteria can grow. And our whole digital world, all of our data storage, megabytes, gigabytes, terabytes, that's all based on the power of exponents. So really, that's the whole point of exponents. They take these numbers that are just too big for our brains to really picture, or way too small to even see, and they wrap them up in this neat, tidy little package that's easy to understand and work with. They make the complicated simple.
And that brings us right back to Peter in the museum. That confusing sign didn't just have a big number on it. It had 10 to the power of 8 years on it, a truly immense amount of time. You see, exponents aren't just about solving math problems. They're a language that lets us understand the incredible scale of our universe. So, next time you see a number that just seems impossibly huge or ridiculously small, think about it. How could you use the power of exponents to make sense of it all?